So here is the question. A tennis ball is dropped on the floor from a height of 4 meter, which means the initial velocity is 0. You're going to find the final velocity by using the formula. V square minus u square is equal to 2as, where u is 0, v square is 2 into gravity, which is 10, into height, which is 4, so 80, and v therefore is root of 16 into 5 is 80, so 4 root 5 meter per second is the velocity which it's going to hit the floor. So this can be taken as u1, the velocity with which it's hitting the floor, though it's a final velocity in here, you can take it as u1. Then they've given that's going to rebound for a height of 3 meter, which means in this case the final velocity is 0 and you're trying to find the initial velocity in here. So again put v square minus u square is equal to as, where you know the final velocity is 0, you're trying to find the initial velocity, gravity will be negative, so let's assume it as 10 and then the height is 3. So this itself is 60, so u square is 60, as u is equal to root of 60, and you know 15 fours are 60, so it's 2 root 15. So this is 2 root 15, and that is your velocity u2 with which is getting rebound, and acceleration is change in velocity v minus u by t. But here what is v is the final velocity with which is getting rebound, which is 2 root 15 minus initial velocity, which is 4 root 5 by the time taken. The time at which it's in contact with the ground is 0.01 seconds, and this will fetch your answer. Okay, so that's the sum. A stone falls from a cliff, a height of 24 and moves through a distance of 24.5 meter in the last second, which is nth second. You don't know what is that nth second. The formula for nth second is u plus a by 2 into 2n minus 1, and this distance through which it's fallen is given to be 24.5 is equal to, it's falling from the cliff, so initial velocity is 0, plus 9.8 by 2, or you can even take it as 10, and a 2n minus 1, let it stay as it is, and this is 4.9. So it's 24.5 by 4.9 is equal to 2n minus 1. In the question they seem to have taken it as 25 and a 5, and so then move it to that side. This itself is 5, at 2n is equal to 6 and n is equal to 3 seconds. Is the time it's taken for this nth second, which means the total time is also 3 seconds, because if it's going to take third second, this movement last second happens to be third second, the total seconds is also 3 seconds. Therefore you understand the total time is 3 seconds. Then they are asking find the height of the cliff, the total height of the cliff, for which you can write the time s is equal to ut plus half at square. Time is 3 seconds, the total height, initial velocity is 0, plus half into, let's take it as 10 as the gravity, into t square is 9, so it's 5, so 45 meters is the distance. So that completes the sum. The next sum, is here. Starting from rest, a car accelerates uniformly with a velocity of 3 meter per second square for the first 5 seconds, and then moves with a uniform velocity. So 6th and the 7th second, the total time is 7 seconds. You have to plot a graph between position and time, for which you have to do this tabular column. How to do that is by taking s is equal to ut plus half at square. When time is equal to 1, initial velocity is 0, because it says car starts from rest and it accelerates at 3 meter per second, so acceleration is 3 and the time is 1. On substituting half into 3 into 1 square, it will be 1.5. When time is 1, the distance is 1.5. The time is 0, the distance is 0. And the time is 2, ut is 0, half into acceleration is 3 into 4, and so then therefore 2 means it's 6. Like this you plot it till 5 means that's 1.5. In the same formula, keep substituting. T is 1, T is 2, T is 3, T is 4, 5. Okay. At 5 you have to find the final velocity, because after that it's not going to accelerate. So for which you're going to use the formula v is equal to u plus at, where v itself is what you need to find. Initial velocity is starting from rest, acceleration is 3, into total time is 5, so you know that 15 meter per second is this velocity here, after which is not going to accelerate. In the 6th minute and 7th minute it's going to cover 15 meters plus another 15 meters. That is to be understood. Okay, so now you're going to plot a graph. You have add 15 to this and add 15 to this, so that the total distance will be can be written in S. These two columns has to be written in a special way, as I said, and then you have to just plot a graph. And so the graph is this. For every point you just plot it and you get it as parabolic. And so that's about that sum. They have asked you to plot the SD graph, displacement or distance time graph. Okay, so next question is this. As you can see that the moment you see there is a B which is in red color and A slope which is in black color, it shows that B is already ahead. Can you see it starts from here? From the graph, you know B is already ahead of A because this distance is already at 100. So what are the observation? B is ahead of A. Then they ask you for how much ahead of A is B. So this 100 meters is the distance is ahead. First question is answered. Second question, what is the speed of B? Speed is, this is a distance time graph. If you do the slope, you get the distance. Speed of B. Let's do a slope for B. Can you see it's opposite by adjacent? This itself is 50 units. This itself is 2 units. So 25 meter per second is the speed of B. Next, supposing they ask you speed of A. Supposing, where is your A? This is your A, and we can do a slope for A. Slope for A will be this opposite by this adjacent, and this itself is 150 and this itself is 2, and 75 meter per second will be the speed of car A. So when and where the car A and B meet, you know they both are meeting at this distance. When means 2 seconds, where means at 150 meters. So that answers the third question. What is the difference between speed of A and B? Just subtract 75 from 75 and 25. So 50 meter per second will be the difference in speeds. So that answers all these questions. Okay, so let's go to next one. The speed time graph of, okay, next is this question, which is a speed time graph of particle moving along a fixed direction. There's a figure given. I'm just trying to look at the figure. The figure is not here. So then leave that sum. Let's go to 37th question, which is in here. Okay, let's look at the 37th question. They have given this graph, which is a speed time graph. The speed time graph particle moving along a fixed direction. Okay, so then if you find the area under the speed time graph, you know area is like integration. So velocity time graph, it will get you displacement. Here it will get you distance. So area of this triangle is half into base is 10 into height is given to be 12 units. So then 60 square units is the area, which will be 60 will be the distance. So the distance moved is distance traveled by the particle 0 to 10 seconds. Yeah, we have done it for 0 to 10 seconds and we found it to be 60. So the first question is answered. The second one, the average speed between this interval. Average speed between this interval? Between the average speed. Change in the average speed can be written as change in position by change in time. What are they done for finding the, so the 60 meters is done, you can see. Okay, let's go, let's see what they've done with the next one. For the average speed is the total distance travelled by total time taken. The total distance itself is 60. The total time taken as per the graph. Can you see, this is the way you should write, total distance by total time taken. I was thinking of change in position by change in time. That's only average velocity. This is average speed, which is total distance by total time taken. So 60 by 10, 6 meter per second. Speed is minimum at t is equal to 0. So when is the speed minimum and when is the speed maximum? You can interpret from the graph. And speed is minimum and maximum. At a time t is equal to 5 seconds is where at 5 seconds is where the graph was at its peak. Can you see? So that's when it's maximum. Such an easy question. So let's go to next. A body starting from rest accelerates uniformly along a straight line. Hope it's getting recorded. Yeah. So this is the graph that's been given. A body starts from rest uniformly on a straight line at a rate of 10 meter per second. You know this is a velocity time graph. And the slope of this will get you an acceleration. And they've given that 10 meter per second square is the acceleration for up to 5 seconds. You can see from the graph, up to 5 seconds is here. The slope is opposite by adjacent, which is 50 by 5. So 10 meter per second square, correct. Was the graph given or you're supposed to draw? A body starting from rest. So you're supposed to draw. The moment they give you 10 meter per second square for 5 seconds, it moves for 2 seconds with the uniform velocity. Okay, and then the uniform velocity 50 meter per second square. And then, so therefore you know that you have to draw a 50 here. Then you know that it's going on, acceleration is increasing. The slope itself is 10, which will be 50 by 5, it makes sense. And then you can complete this graph accordingly. If it moves for 2 seconds with uniform velocity, and then it retards uniformly, comes to rest. The deceleration, this means it's acceleration, this means it's deceleration in 3 seconds. So then 7th, 8th and 9th, 7, 8, 9, 10, that gap 3 seconds is coming down. You should know to plot this graph. So the hint is here, you should start with this. It moves with a constant velocity, you know. That is what gives you the hint to do the sum. I'm sorry. So you have to complete the graph, and once you draw this graph, if you find the area under this, the complete area, okay, probably they're asking you to find an area for particular time. Let's see, find the total distance. Distance means area. You have to find the area to get the distance, correct? Because velocity time graph, integration or area under the graph will give you distance or displacement. So then area between, find the total distance traveled with about total distance. So you have to find the area of this. Okay, let me so basically you have to find the area of this region plus area of this region plus area of this region, and you know how to find it. And once you find this area, you can add all those areas, and that will give you the, or you can treat it like, you can even treat it like a trapezium, and that's what they have done, half into S1 plus S2 into H. You can even try to treat it like a trapezium. This is S1, which is 2, and S2, which is 10, and the height is 50. So with that you can do the sum. Okay, so let's go to next question. So these are the kind of graph questions. Unless you understand that the area will give you one step lower, which is displacement or distance, you can't do this sum. So next question is here. This is again a graph has been given. I hope the graph has been given, a figure has been given, yes. So when the figure is given, it's easy. If you have to draw the graph, then it gets difficult. A train moves from one station to another station in 2 hours. So you should first slowly read this question, how it's moving. How, which means, can you see at A to B is at a constant velocity? The fact that for A to B is a constant, it's going at a constant velocity. This is at a constant velocity. Here it's accelerating. Here again it's accelerating. Here it's decelerating. All these things again you can easily interpret. Determine the maximum acceleration. Acceleration is nothing but slope. Speed time graph would slope the acceleration, which is very steep. Can you see this is the part which is very steep, BC. So that's the maximum acceleration that I can think of, which is opposite by adjacent. The opposite is 50 minus 20, 30, and the adjacent is, you have to figure out what is this gap. It's 1 minus 0.75, 0.25. So you just divide 30 by 0.25, you get that acceleration. Also calculate the distance covered during the time interval, 0.75 to 1 hour. Where is 0.75? 0.75 to 1 hour, this whole distance they are asking. Speed time graph would area, the area is half into S1 plus S2 into height. Okay, that will give you the area under the graph, which will be your distance covered. So it's as simple as that. So this is the solution also has been given. You try to do the sum using the graph and verify with the solution. So next question is, okay, the moment I see this velocity time graph, I know this is about the upward motion. As I taught you in the class, this is ball thrown up. ball thrown up, and this is the ball which is coming down, because at the topmost point the velocity is 0. So that's this graph. You understood this graph. So probably are they asking for that only in the question? Let's see what is the question. A ball is thrown upward with the initial speed of 100 meter per second. After how much time will it return? Draw the velocity time graph for the ball, and from the graph the maximum height attained by the ball and the height of the ball after 15 seconds. You yourself can understand this sum and do this sum, and you want to find the height, velocity time graph. If you put the area under this graph, you will get the displacement. You'll actually get the displacement. You have two regions. See, basically you have this region. I'll just come out of this once again. You have to find the area of this region and also this region, region 1 as well as region 2, and you can write this to be a positive value and this to be a negative value, because what you get is a displacement. And so once you do that, so what first of all is to plot this graph. You have to plot this graph, and they've used the formula B is equal to U plus AT. The final velocity is 0 for a ball thrown up, and U is initial velocity 100 meter per second. Acceleration is acting downwards, so minus 10 into t, with which they found the time for the ascending journey. The time for the ascending journey has been found. Okay, so then next is so you know how to draw that graph also. It's taken 10 seconds. That makes sense for you to draw. From 0 to 10 seconds is when the ball is coming down. After 10 seconds, what's happening? The ball will return to the ground. Time of ascent is equal to time of descent. So another 10 seconds is going to take for the ball to come to the ground. So then they have just B is equal to U plus AT, and the velocity of the ball at different instants of time they have just mentioned here. With what they are plotting this graph, I hope you understood. The downward journey, the topmost point is 0 and then it turns to be minus 50, and you can understand this graph. And they've drawn it till 20 seconds, correct? Because time of ascent is equal to time of descent, they've drawn it till 20 seconds. Maximum height attained by the ball. Maximum height attained by the ball is determined by the area of triangle AOB. Because the question is about maximum height, so it's about upward journey alone you can take. Just the top graph alone you can take and find the area. That's 500 meters, that's what they have done. And what else is the question? That's all is the question. So you should understand that you have to take only the first triangle, top triangle, not the down triangle, because maximum height is determined only by the upward journey and not by the downward journey. So let's go to the next question. The velocity time graph of this is given. Draw the acceleration time graph. They've already given velocity time graph, acceleration time graph. You know, slope of velocity time graph is acceleration. And as you can see from here, acceleration is opposite by adjacent, which is 2.5 by, opposite is 20 by 2.5. And this 200 by 25, which is 8 SAR. So then therefore this is acceleration is 8, constant acceleration, but here there is no change in velocity, so acceleration is 0, and here the acceleration is negative acceleration, which is again opposite by adjacent. Opposite is again 20 by adjacent is, opposite again is 20 by adjacent is 2, so it is 10. It's minus 10 meter per second square because it's decelerating. So then therefore you can write the graph, and acceleration can be positive and negative. So this is minus 10 is 1, another is 8, plus 8 is this constant acceleration. This is your x-axis and this is your y-axis. So then for this for some part of the journey, it's based on time. So first 8 is for 0 to 2.5 seconds, 0 to 2.5 seconds. So you should not do this here. Okay, you should continue with the graph. Let me do it here. So 0 to 2.5 seconds, it's plus 8, then it is 0, and then it is minus 10. Okay, so the graph has to be shown like this, and this is your x-axis and that's your y-axis. Let's see what he has done. Yeah, so here's the acceleration graph for it, and so you understood how I've drawn it. So that's all. These are the questions that you should know.